Next, on solving right angle triangle, we are going to consider how to use trigonometrical ratios in solving right angle triangles. In the last 3 video clips, we were looking at our first tool, the Pythagoras theorem. Now, trigonometrical ratio is another method we can use. Here I have the triangle ABC. All 3 sides are stated as small letter A, small letter B, and small letter C. None of the angles there is provided. By angles, what do I mean? I mean, let me change my marker here, please. The color. All right. I refer to this angle there and also this angle. Well, already we know that this is 90 degrees. How do we operate a right angle triangle when we know any one of these angles? We are going to bring them now into the picture. We have not been considering that all this while. Let's look at the first one. Here we have triangle ABC, and we are looking at the angle down here. And that angle has been provided and it's called theta. How do we then label our sides? We have known right from the Pythagoras theorem that the side that is facing the right angle, that is a 90 degrees, the side facing it is called the hypotenuse. We have not labeled the other 2 sides all this while. Look at where the angle theta is provided. The side that is facing the given angle theta in this case is called the opposite side because it's directly opposite the provided angle. And then the last side, since we know we have just 3 sides in the triangle, is called the adjacent side. What about if the angle were to be up there? Will the naming still be the same? Let's see. Here again we have another triangle labeled again ABC. This time around our angle is now up there. Hypotenuse still remains the side facing the right angle. Now we said that the side facing the provided angle, this angle theta, will be opposite, and that's just the same in this case. So here the side B is the opposite, and then of course the remaining side is the adjacent. Now with this we can jump into defining our trigonometrical ratios: sine, cosine, and tangents. These are the basic trig ratios. Others are formed out of these 3. So first we look at the sine. What is the definition of sine? The sine of an angle is simply defined as a ratio of the opposite side to the hypotenuse side. So I have an angle theta. The sine of that angle theta, sine of the angle theta, is simply defined as what? As a ratio of the side considered to be the opposite in that triangle to the side labeled as the hypotenuse. Now this also implies that trigonometrical ratios in this form cannot be used except it is a right angle triangle, because we must have a side that is hypotenuse. If the triangle is not a right angle triangle, then there will be no side called hypotenuse, and the idea of opposite and adjacent will be of no use. So here we can see that sine of the angle theta is opposite of hypotenuse. How do we get this abbreviation? S stands for sine, O stands for opposite, and the H stands for hypotenuse, as you can see there, opposite and hypotenuse. So normally we call this so. Very soon we'll find out for cosine we call it ka, and then for tangent it is toa. Let's advance and look at the definition for cosine. Cosine, as I said earlier on, is defined as a ratio of the adjacent side, that's the adjacent side, to the hypotenuse side, and of course abbreviated as what? Ka, saying that cosine is equal to the adjacent side divided by the hypotenuse side. We take the last one, the tangent, toa, which of course by now we all understand this, that the tan of an angle is what? The opposite side divided by the adjacent side. That's why you arrive at what? At TOA. Now with these three tools, we can handle trigonometrical, so we can handle right angle triangle when Pythagoras cannot do it. Look at our first example. Here we have a right angle triangle ABC. We are asked to solve for the sides labeled W and Y. At first I asked myself, why can't I just apply my Pythagoras? After all, I know Pythagoras simply says that the hypotenuse square, which is W square in this case, is equal to what? The sum of the squares of the other sides. The other two sides are the y square, W square, Y square plus 14 square. Of course, the hypotenuse is AB, which is where I get my W from. Y is what? BC, which is the length of one of the two sides. And then my 14 came out from what? AC. But looking at this equation, only one value is known. There are two unknowns. Obviously, there's no way I can solve for these two unknowns using only one equation. And that is the limitation of what? The Pythagoras theorem. How then can I apply the trigonometrical ratio? I look at this, I've been given one of the angles, 50 degrees. Immediately I say, okay, out of the three trigonometrical ratios, which one am I going to use? First, I have to decide between W and Y. Which one do I look out for first? I say, okay, let me find Y first. That's my own decision. You can decide to find W first. It doesn't make any difference. I said, okay, if I'm going to find W first, then I need to know, look at the angle 50 degrees and look at Y that I'm looking for. Is it the opposite side? Is it the adjacent side? Is it what? Is it the hypotenuse side? Let's try to label this triangle properly. AB is the side facing the right angle, therefore it is the hypotenuse side. And since we are not looking for W, so we have nothing to do with hypotenuse for now. So hypotenuse, go and sleep. And that's okay. What about the 14? Oh, it is facing the provided angle. So that must be the opposite side. I said, okay, opposite is going to be part of this game. And of course, the remaining side must be the adjacent side. So okay, I must use a trig ratio that combines the opposite side. Please let me change the color of my marker. That combines the opposite side, in this case I've been given, and the adjacent side, which I am looking for. And I look at this, I say, oh, so TOA. Which of you can help me out? Sine says, sorry, I have hypotenuse in me, I can't help you. Cosine says the same thing, I have hypotenuse in me, I can't help you. But tangent says, no problem, you are free to come. I'll take care of you because I am the one who operates adjacent and opposite. I said, beautiful. So I set out to do my job. And I said, okay, what is the tan of the angle 50? Tan 50. It is opposite of adjacent. Oh, opposite is 14. And the adjacent is Y. And I can say, oh, this is an equation. This is an equation where Y is the only unknown, which means I can easily solve for my Y. Let's move to the next slide. Yes, on this slide you can see some advanced work already. The tan of 50, of course, is what? Opposite over adjacent. The opposite is what? 14. Adjacent is Y. Tan of 50 is 1.19175, so we approximate and get the 8 there. Equals to 14 over Y. Then manipulate this. We'll agree that Y will be what? 14. Okay, let's take it this. Let's cross multiply. This is 1.1918Y equals to 14. So my Y will be what? Will be 14 divided by 1.1918. And that will give us, take your calculator, and we have there 11.75 as my Y. Now I know my Y. The next thing, how do I get my W? Well, For those of us who are in love with Pythagoras theorem, you can simply say, okay, since we know y, why not just go and apply Pythagoras and say w square is equals to y square, which is now known, plus 14 square. Of course, that will work. And this will give me 11.75 square plus 14 square. And the rest is history. But well, since I'm playing with trigonometrical ratios right now, I still want to indulge the trig ratio. So let me use trig ratio. Please pardon me for that. But you can go ahead and get the answer for this from this page. I move to the next slide. I decide that I want to find W. So hypotenuse is coming into the game. I say, oh, hypotenuse. You can play with sine and you can play with cosine. So which of them do I use? I say, okay. Hypotenuse is saying, sine says opposite of hypotenuse. And cosine says adjacent of hypotenuse. I say, which one do I use? 14 is my opposite. It doesn't have decimal. If I want to use the adjacent, that's 11.75. I'm a lazy man. I think I should just go for 14. And 14 is opposite, so I'm going to apply sine. And that's why we see here, sine 50 is what? The opposite over hypotenuse. Opposite is 14. W is the only unknown there. Manipulating this, we can get our W. Of course, you will agree with me that if you cross multiply here, we have 0.7660W equal to what? 14. And of course, it means your W is what? 14 divided by that. Let's proceed. Next slide. That's it. W is 14 divided by 0.7660. And we arrived there that W is what? 18.28 centimeters. We take one more problem. We are asked to find the angle in triangle ABC. Of course, you can see here that Pythagoras will be completely defeated here. This question is looking out for what? The angle, theta. Pythagoras does not do anything about angles. And this is a right angle triangle. Pythagoras has been beaten out of this game. So we go to our our tool that relates sides with angles. And I look at this. What sides are these? Two sides have been given. How do I combine them? I say, okay, if I look at this triangle properly, this side is facing the right angle. It must be the hypotenuse side. So I need something that has to combine hypotenuse because I've given that. This side, the opposite side is not known because it's facing angle theta and it is not known. So we don't need the opposite side this time around. Opposite side, sorry for you, we don't need you. So we are going to use the adjacent side and the hypotenuse. Of course, you will agree with me that who is going to be the guy? That cosine is going to do the job because it combines adjacent and hypotenuse. And I quickly say, okay, the cosine of angle theta is what? The adjacent side, 15, all divided by the hypotenuse side, 22. Remember that cosine is adjacent divided by hypotenuse. Of course, convert this to decimal form, and we have that cos theta there. It's 0.6818. 0.6818. How do I therefore find my theta? Of course, from basic trigonometrical ratio. So you can say that cos, you can use it with your calculator, is the cos inverse. Theta is the cos inverse of that value, 0.6818. You can use your four-figure table or you can use your calculator to get this. And straight away you check this and to give you that angle theta is what? 47 degrees. So you can see the relevance of the trig ratios complementing the work of what? Pythagoras theorem, which only handles sides. In the next video, we'll look at more problems using trigonometrical ratios to solve them. Thank you.